Thank you very much for waiting. Let's move on to the next session on the theme of Quantum Ecosystems and Frontiers of Quantum Technology Development Across Nations. The panelists for this session are Ms. Sabrina Maniscalco, CEO and co-founder of Algorithmic. Ms. Lisa Lambert, CEO of Quantum Industry Canada. Ms. Hanhee Paik, Director of Quantum-Centric Supercomputing Partnerships at IBM. The session is moderated by Mr. Masayoshi Terabe, Chief of Quantum Technology at Deloitte Tomax Consulting.
Okay, everyone, thank you for joining to this session. I'm really honored and excited to be here. I'm Masayoshi Terabe, Chief of Quantum Technology at Deloitte Japan. I have been more than 10 years being involved with quantum application development and investment, etc. So before the talk session, let me briefly introduce the quantum ecosystem and industry overview from my side. So let me introduce the big trends, three big trends of quantum computers. First, quantum market will be from 450 to 850 billion US dollar in 2040. It's very huge market compared to AI. It's bigger than current AI market in the future. So second, tech giants are developing their own hardware. IBM, Google, Amazon, Microsoft, Intel, Fujitsu, etc. So after digital, quantum will be the big competitiveness point in the future. Then there are many quantum hardware development challenges to overcome. However, currently, milestone is really accelerating. For example, quantum itself is very sensitive to noise. However, the error correction technology was realized last year. It was thought about to realize in 2030. However, already last year realized. So it will be accelerating. So what will be useful for quantum? Quantum is social transformation after digital, I think. As you know, digital changed the world drastically. Digital technology is based on computing technology. However, quantum is also computing technology transformation. So there will be the big transformation, same as digital in the future. Quantum computer will be accelerating drastically in specific problems. The application will be including some social changing problem. For example, if we could realize highly efficient artificial photosynthesis material, we could solve climate change problem in the future. So if we could realize high precision drug simulation, we could discover medicines for untreatable diseases. So we will save more lives in the future. And then we might realize high efficient machine learning. It will risk realizing more powerful and ultra low power AI. Some people said AI performance limitation will be the power consumption. So if we could realize low power AI by quantum computer, AI will be more powerful. Towards those big applications, there are already huge investment in quantum startups. You can see 10 top funded global quantum startups. There are already some unicorns and IPOs startups already, even in the before the practical timing. So this chart shows the government and private sector investment. Globally, many of governments, including the Japanese government, are investing and commitment in quantum. Green circle shows the government investment amount. There are so huge investments already. And blue circle shows quantum startup funding. There are huge funding. Of course, US startups got huge funding. However, also Canadian startups, European startups got already huge funding. And also, in Japan, there are good news. Great quantum hardware startups launched their business from 2 or 3 years ago. So there will be a good potential to enlarge the quantum market in the future. So today's speakers are very famous people who's leading quantum ecosystem in the world. Sabrina from Algorithmic is from Finland, and Lisa from QIC from Canada. She's leading quantum ecosystem in Canada. And Hanhee, she's in Japan. However, she's a leader of IBM Quantum. IBM has been leading quantum ecosystem in the world. So today, we are going to dive into what kind of market will be arising. What should we do at this moment? Yes. So from now on, let's start talking with these speakers. So first of all, I want to ask you to introduce yourself and your initiatives. So please first from Sabrina.
Thank you very much. It's a pleasure to be here. I'm Sabrina Maniscalco. I'm CEO and co-founder of Algorithmic. Algorithmic is a quantum software company with headquarters in Finland and offices in London and Dublin. And we work mainly in healthcare and life sciences as a vertical, but most importantly, using today's and tomorrow's quantum computer and making them already now useful for real world and impactful application. So what we do is really to, in a way, solve all those roadblocks, the difficulties that today are affecting this technology. We have heard about noise and errors that are dominating quantum computers. And then we identify the useful applications that can bring value in industries like healthcare and life sciences. So in a way, we bridge this gap between what can be done today and what is useful for our end users and clients.
Yeah, great. So let's go, Lisa.
It is such a pleasure to be here. I lead a consortium called Quantum Industry Canada, or QIC, and we are the national business-led consortium uniting quantum technology companies and strategic partners together to help advance the sector. We work with quantum technology companies not just in computing, but across all different types of quantum technologies. And this is a very new paradigm for technology for us. And a lot of how I think of what we do is we work together with the community, we do some ecosystem building, and we help pave the road in front of us to move into this new future, this new technological platform that is very transformational. We're starting to see some of that today with work that's being done here, and a lot of exciting promise and potential that's going forward. Canada had a very early start in this, and so we have a very vibrant ecosystem, and we're home to the highest concentration of quantum startups per capita in the world.
Amazing. So let's go, Hanhee.
Hi, my name is Hanhee. Actually, I live in Tokyo, so it's really happy to be here. So I'm from IBM. So IBM is we are computing company. We are also quantum computing company. We develop the science and technology for quantum computing, but in addition to all different quantum computing technologies. And as a quantum computing company, we also work with globally 250 IBM Quantum Network members to also advance the field of quantum computation. But in Japan, we have two dedicated systems actually located in Japan. Actually, one will coming in June, but the other one is in the city of Kawasaki that is powering one of the largest industry consortium is called Quantum Innovation Initiative Consortium, which is led by the University of Tokyo. It has 23 members, industry and academia, and producing already more than 140 papers, and then really truly showing the global leadership that Japan is leading for quantum ecosystem development. And my role is, again, I'm not actually leader of the quantum team. We have Hiroshi Hori, who's the leader of the IBM Quantum Japan team, and then I work with him to basically develop the quantum ecosystem. Especially, we are driving the technology for quantum and HPC integration in Japan. So, yeah.
Yeah, thank you. So today's speakers are looking at various markets in the world. So I want to ask, when and in what business fields quantum computers will have a huge impact in the future, and what are you doing for that? So, from Hanhee?
Where the areas that the quantum computing will have an impact, right?
Yes.
I think I wanted to start rather from the top. So there are three computational problems that we think the quantum computer can help. So simulating nature and processing data where data has complex structures, and also optimization. So those three are the computational areas that we think the quantum computer can help. But those three can really spread over many different areas. And then initially, IBM was focusing on 5 industry areas: automotives and aerospace, and healthcare and life science, and energy sectors, finance sectors, and then also high technology sectors that includes the material science and chemistry. But I believe that right now we are actually in the process of developing algorithms, which is actually has to be done first, and together with academia and industry. And once the quantum algorithms are developed, then we also have to transfer to the industry use cases, which is also another area of the research in some level, or something that the industry has to invest. And eventually, to make the impact, the full economic impact, we believe that at this stage of the technology, the collaboration between academia and industry, and of course, we also need the education, because we need to educate young people to create a quantum workforce. So creating this full cycle of it is very important, and that's why a lot of governments is actually investing it, because we are right now slightly before the time that we can expect any returns yet for investment. That's why a lot of governments are investing it, as Terabe-san was showing. And again, we really have to create this cycle to bring the impact. But I believe that probably I like to also hear your the perspective, because we are the quantum computing company, but then you're actually the end user side of it, right? So yeah.
Yeah. How about Sabrina?
Yes, I can specifically talk about some applications in healthcare and life sciences. There we have both the simulation of nature aspect from some points of view, when you think in terms of simulating drugs, and now they actually interact with the proteins in our cells, in our body. But of course, there are also aspects related to optimization problems, if you think in terms of large data sets that are used nowadays in personalized medicine and so on and so forth. But I want to give you one specific example, because this is the one example, the one use case where we are closest really to a large-scale implementation in drug discovery. This is a collaboration we have with Cleveland Clinic and with IBM, actually. And the specific example is an alternative method to treat cancer that is known as photodynamic therapy for cancer treatment. Photodynamic therapy is a technology, is a method that is particularly interesting because does not have many toxicity side effects. So we know that curing cancer, unfortunately, with chemotherapy or also with radiotherapy, it's very heavy for the patient. Instead, photodynamic therapy works in a way that a patient ingests a drug which is not active. So it's not toxic. It is absorbed by the cells, and it is then activated into an active form only upon irradiation of light on the spot of the cancer. So assume that you have a skin cancer. It's localized. Then you use the light to activate the drugs that then kill the cancer cells. Now, the interesting part is that specifically this process of interaction of light with the molecules that are the drugs is a very quantum mechanical process. So this is an example of where you need really quantum computers and quantum system to emulate a quantum process. And this is exactly an example where we identified from the end users, in this case, the medical doctors, the bioengineers at Cleveland Clinic, a problem, because we know that photodynamic therapy, or they tell us that photodynamic therapy does not have a computational pipeline, cannot be simulated really computationally, and therefore it's really hard to implement because you have to do it in the lab. We realize, well, this is ideal for quantum computers, and we deploy a very complex pipeline that is hybrid. So it uses both machine learning, HPC methods, and quantum computers in order to optimize the drug in silico, so computationally. So this is a completely new missing part which is very much needed. So I want to give you a very concrete example. This work has been backed and funded by the Wellcome Leap Q4Bio project. We are entering the third year, so this means that we have already all the algorithms developed. The molecule identified is a molecule that is already in phase 2 clinical trial, and we are running, as we speak, large-scale demonstrations on quantum computer and HPC. The whole pipeline is transferable. This means that we can apply it to other molecules in drug discovery. This is just an example, but I want to give you something concrete of something that can create value already now in a vertical that is very important to all of us, that is healthcare and life sciences, and for one of the most, let's say, researched illnesses, diseases, that is cancer.
Thank you. It's amazing that such kind of program already have running. So what about collaborating with the corporates, academia, etc., about the ecosystem to realize such application to be practical?
Of course, it's very important to have a healthy ecosystem which combines all the players that were mentioned here. And clearly, in our case, in this consortium, we don't have directly an academic partner. We do have, however, Cleveland Clinic, which is a hospital in this case. But it's important, we believe, that both the business side, the stakeholders, policymakers, and government side, the universities and educational side, we talked about really the creation of a new type of talents, because the type of expertise that you need to contribute to quantum technology is a little bit different from the traditional one. It's much more, let's say, multidisciplinary. You have to bring together not only expertise from quantum physics, but you have to understand, for example, chemistry, biology in our case, and so on and so forth. So, and everybody agrees that one of the key roadblocks is talents or lack of highly specialized talent. So clearly the contribution of university is important, education is important, outreach is important, because this is, of course, a technology that will be adopted massively by society. So we need to explain in which way it will become familiar. And so I think that outreach, especially for new technology and dissemination, is key for adoption. So there are many ingredients, and I think that a lot is happening, much more has to happen. I'm very optimistic and I'm very excited about the specific point in time in which we are, where we are seeing this creation of value and the first impact in society.
Amazing. So, Lisa, you are the leader of huge quantum ecosystem in Canada. So, what do you think about the most impactful application and what timing it will be in practical?
How I think about quantum computing is, in the simplest terms, and you spoke about some of the applications, is really kind of two areas of applications. One is making things, like making new drugs is one area of it. The other one is breaking things, that's where the first algorithm came out for quantum computing back in the 90s as well, was realizing that this new type of computing would be able to hack most of the digital cryptography that we use today. So that is something from a nefarious place, but we do need to be implementing solutions and defenses to that do exist today, and standards came out for that just this past August as well. Timelines, I think it feels like quantum is having a moment right now, and we'll see where it goes, but I think it's important to have a long-term view as to where this goes as well. We saw with computing, it took time for things to develop and go from there, but it's at a moment as things are coming, and I think with drug discovery is really exciting. I think with simulation, anywhere where we're simulating nature and looking at some of the chemistry applications are really interesting, whether that's with battery materials or different areas. And finance is another one as well, where I think even with smaller speed ups in computation, we might see something really interesting on that side. So things are progressing, they're coming along. I've been in and around this field for about 15 years now, and seeing where things have come in that amount of time, and it feels like there's an accelerating pace moving forward. You had mentioned all the big technology companies are working on this. I think what's really interesting is there's a lot of really exciting startups that are working on this as well, and with this being a completely new technology platform, it's really leveled the playing field around this, and we're seeing a lot of surprising things moving forward as well with the innovation.
Yeah, amazing. So, Hanhee, you mentioned about the quantum ecosystem in IBM. So, how many corporates, enterprises joining your ecosystem?
Oh, how many companies? Oh my God, I don't know the number. I mean, I know the total member, we have more than 600,000 users globally. And then
600,000
users of
Amazing.
the users of quantum computing users, but that includes everyone, right? Students, industries, and anywhere, academia. And IBM Quantum Network members are more than 250 members, but they include startups, the full industry, and of course university. I mean, I think we do have more university members than the industry for now. And then government labs, so those are actually more dedicated working with us. So we have a lot of people. Industries, I cannot, this is a recorded, so I cannot really guess the number.
Yeah.
But there are a lot of them. I mean, I'm sure, I think, you can ask a Canadian guest also, if you want to ask. Yep.
Yes.
Anyway.
I think many people think quantum computer itself is just no practical computer at this moment. However, why user companies should starting use quantum computer now?
Actually, I'm going to make the Japan as an example, because Japan Quantum Innovation Initiative that led by the University of Tokyo, and their Keio University and RIKEN are part of the QII. I think they have 19 industry members in there. 18 or 19 industry members. So they include Sony, Toyota, Hitachi, Toshiba, Mitsubishi Chemical, JSR. Okay, I'm gonna miss a few, but anyway, more, and then etc. Right? So they're actually doing research together with the university. They started in 2020 as earliest. I guess they didn't start like a full 19 members, but I think the few JSR Mitsubishi Chemical are one of those early members who started this QII consortium, that industry and then academia. But they're right now doing more like a research and development because their vision is we really need to work on algorithms first. And before we actually jump on to looking into use cases. So this fundamental research, especially using the quantum computer, is very important, and they see the vision there. So these are intellectual properties actually really important, especially at this stage, and then show the leadership. The industry is showing the new technology leadership to the world I believe that's a really huge value. And I mean, that's why the number of members is increasing. Especially right now, the quantum computing technology is also going up, right? Now, IBM is producing more than 100 qubit systems that can run more than 5,000 entangling gate operations. And with the error mitigation techniques, the quantum computing computation results can actually be useful. Some of the results are, can be comparable to the classical HPC results, such that the quantum computing results can make it to the lot of scientific papers. So that already shows our leadership. And then the knowledge that you accumulate for the past 4 years, I'm sure the Japanese industries that are part of the QII is way ahead of the curve than any of the people from the rest of the globe. So in there's a value, right, to invest in the early stages of the technology in quantum computing.
Okay, I see. So Sabrina, what do you think about why user company should start at this moment?
Well, one of the main reasons is because we are discussing about a technology that, of course, not alone, but combined with HPC, will be the next exponential technology. So we are talking about something that will change society. For certain industries, this has massive consequences. Because, for example, in the example of pharmaceutical, the acceleration of the deployment of a drug, so the reduction of costs and the reduction of times that will be possible by using quantum computers combined with supercomputers will make obsolete really existing methodologies. But in order to reach that level, that stage, it is important to identify already now what are the use cases, what are the needs, and what are the capabilities that need to be growing within the company. And this is something that requires time and therefore requires an effort that starts already now. In fact, now is already late, to be honest, because the competition will be such that only those companies or biotech or pharmaceutical, for example, I'm making this example, but what I'm saying is actually applicable across verticals, to all the verticals where actually quantum computers can provide a disruptive impact. So we're already late because the companies that have already started are ahead. And the transition will be fast. The technology is growing fast. We are very close to the first inflection points in which we will demonstrate that quantum computers combined with HPC will outperform anything that can be done classically. And then there can be a steep change. So as a company, you need to be ready to leverage and exploit this potential. And you have to do it now. Later will be too late.
That's amazing. And Lisa, as you mentioned, Canada has the most number of quantum startups per capita. We are really respecting about that. So how did you start that
It started a while ago, and I think that was a big thing. Canada was one of the first countries to see the potential with quantum, and actually going back to collaboration with IBM back over 40 years ago now, someone named Gilles Brassard, in partnership with Charlie Bennett from IBM, came up with the first quantum cryptography protocol. It's a little bit separate from quantum computing, but in this space, with that, we've been very active in a field called condensed matter, which has been really critical for the development of quantum computing and technologies. And we've had some other institutions coming through. Canada is home to the Institute for Quantum Computing that was founded in the early 2000s, that is the world's largest center for quantum computing. And there's been a lot of really interesting research coming out of there and startups. We have a very strong academic community. We're known for our research excellence with that as well. And we were also one of the first countries to be moving quantum computing into industry. So we're home of D-Wave that was founded over 25 years ago now, which is the first company to sell a commercial quantum computer. We're home to 1QBit, which arguably founded the quantum software industry. First pure play quantum software company was founded back in 2012. And we've had a number of these other companies. We're also home to the Creative Destruction Lab. And with their quantum stream, they're one of the oldest accelerator programs for quantum startups in the world. And they've seen about 160 startups come through the program now, and it's shifted a little bit, but at a time, 1/4 of the world's startups, our quantum startups, had been through the Creative Destruction Lab. So we've been at this for a long time and thinking about it from a commercial lens and thinking about how do we pull this technology forward into industry and into the market. And I think what we're seeing now in Canada is that's been paying dividends a little bit as we're coming into more of the, I mean, still a long way to go and it's still nascent, but starting to see an emerging industry come around globally.
Okay. How many quantum startups are there in Canada?
We track over 70 companies.
Over 70.
Yeah, and part of that, those aren't all pure play quantum, I want to mention, and they're not all quantum computing. So that's across all verticals of quantum technology and then some of the enabling technology as well.
Okay. What kind of startups are there? Maybe audience cannot imagine what kind of startups are in quantum.
Yeah, I mean, there's a whole range of it, and I think it's interesting to look in the Canadian landscape. So we have startups that are unicorn scale in what they're at. So I mean, D-Wave was founded as a startup. That's grown up more as a publicly traded company now. We have Xanadu, which is another unicorn-sized startup as well to look at. We've got Photonic, which is partnered with Microsoft, and another big player in that space in the quantum computing side. We also have much smaller companies. We have some specifically working on algorithms like Software Q and some others that are at a smaller scale. We have some really interesting enabling technology companies like 0 Point Cryogenics, which works on dilution refrigerators, which is a really key part that we need to chill these systems down to zero. And then we have some small companies coming out. We were one of the first countries in the world to found something called a quantum venture studio, where we're actually working on creating and scouting for new technology and new startups. So companies that participate in QB Studio, they go through a 3-year program where we're pulling the science out of the lab and bringing them through what's needed to pull that forward. So they've recently launched 2 new startups that have just been incorporated, with some more in the pipeline as well coming forward. So you can see everything from these small companies through to what's scaled up to be over 200 people and more in the space.
Amazing. Sabrina, I'm really surprised about the Finland quantum ecosystem because not only algorithmic, also IQM is also huge. Why Finland could raise up those companies?
Well, of course, Finland has a strong tradition in called ultra-cold temperature physics. That is the technology that is behind the superconducting qubit. So when it comes to hardware, and in particular superconducting qubit infrastructures, they have tradition and they have incredible infrastructures available already. So clearly, there have been in the past very successful example of spin-off of the university. For example, I cannot remember the company. It's like a moment that the refrigerators. Blue Force, exactly. Blue Force. Yes. Blue Force is providing enabling technologies like these huge refrigerators that are used by all superconducting qubit companies. So there is clearly at the same time a good tradition in the university, good infrastructure, sufficiently small country, and there is obviously transfer of knowledge that is in place. So the right conditions.
Okay, thank you. So, Hanhee, what will be the main challenges to overcome to be in practical of quantum computing?
Oh,
Yeah, I think there are many.
Practical. To be honest, we just announced the quantum utility, right? Right now with the existing, well, at least with IBM quantum systems, you can actually compute something meaningful that is a competent competitive to the HPC results. So right now it feels like actually the point that we are, the quantum computing will be more and more useful as time goes, and especially in Japan. I'm representing Japan, by the way. There are a huge initiative funded by the Japanese government from MERI, which is led by RIKEN, which is the integrating quantum computers with Japan's national Fugaku. This is a made in Japan quantum supercomputer, and the Fugaku system will be connected to, one IBM quantum computer is one of them. So with the quantum and HPC, we really think that we may be able to see some advantages. Again, it could be quantum advantage with a computational advantage, or it can be quantum economic advantage that I think Lisa was telling me before the events. But that quantum and HPC integrated system will be very useful to the users, and especially for the industries. And by the way, we are talking about startups, and then I think Japan should probably invest more in a startup. Because when I saw, especially this kind of computational tools are available, funded by the government, and now is really time that how we can incubate more of the business, right? Especially coming from the startup that can leverage this high technology. And again, Canadian case is very impressive, right? Impressive. And then Algorithmic is a startup that doing a lot of work. And I hope that in Japan also exploiting, leveraging these new computational technologies that Japanese government is investing. I hope that we can have more investors also coming to Japan to invest in the quantum startups in Japan, because there are also a lot of talented students and people here.
Maybe if I can add to what Hanhee said, we working with IBM, we have demonstrated already a very large quantum utility experiment that uses this error mitigation. Error mitigation is, you can think about it like when you have the noise cancelling headsets. It's something similar. It removes the noise of the quantum computers. And this is something which works for 90 qubits, more than 4,000 entangling gates. So it's massive, the largest useful for science, in particular condensed matter demonstration, which is enabled by these error mitigation techniques. So you can remove noise. We do it optimally. Optimally means that it is not possible to do better than these by the laws of quantum physics. And importantly, I connect again to what you were saying, in post-processing, meaning that we don't touch the quantum computer to remove the noise, we just use HPC resources. So the combination of HPC and quantum computers is key also to enable to go towards quantum advantage. And we are currently working again with IBM on quantum advantage demonstration because we already outperform many of the classical state-of-the-art method, but we want to outperform all of them. And this is hard because, classical computing has been evolving for many more years than quantum. So to beat classical method, it's hard. And you have to understand exactly in which field of scientific relevance first. This is what I call scientific quantum advantage. That will come before the commercial one. But where is it exactly? That sweet spot, if you want, where you can do something which is useful to the scientific community. It is on today's quantum computer, and it beats any competing classical methods. This is happening as we speak, and we are confident that we can have results by 2026 in line with the roadmap of IBM.
Okay. Not only diving into application, but also diving deep algorithm, including error mitigation, etc., is really important at this moment. Yeah, thank you. Yeah, and a little bit go back to Hanhee's comment. Thanks for the comment for Japanese ecosystem. Yeah, I thought as for the comment of Lisa, they are doing, Canada is doing quantum startup incubation activity. That's impressive. Currently, Japanese government is already investing in quantum facility, etc. So, by leveraging that, I think we should also start such kind of activity. I thought, yeah, thank you for your comment. So, we have only 4 minutes to rest. So, finally, I want to have your comments. What kind of activity you want to do with the audience today? So, starting from Sabrina?
Activities with the audience, or maybe a take-home message?
Yes.
Yes, a take-home message maybe for the audience. I believe the main take-home message is that after many years of developing the technology, I didn't say it before, but I've been working before founding Algorithmic. I am still a professor of quantum information and computing. I've been working with quantum technology for over 20 years. And when I was, a PhD student and developing the first examples of quantum physics for technology, we didn't think at all that we would reach a level where we are now. So I've been seeing the progress, and I see now that we are very close to one of these important points where we will see, I call the inflection point, where we will see adoption. Of course, for this type of technology, one has to think in the long term because a lot has to grow. But I believe that timing-wise, these are very exciting time, and the impact is not incremental, it's disruptive. This will profoundly change our society, and it's the most exciting time to be alive for me, to be honest, and to be in Algorithmic.
Thank you. So, Lisa?
I would say this year, 2025, has been declared by the United Nations as the International Year of Quantum. And it's celebrating 100 years of the discovery of quantum mechanics. And we take quantum for granted. You interact with quantum every day, and our world works because of our understanding of quantum mechanics. A GPS, if you use the GPS system to navigate here today, you were using quantum mechanics. The lasers that we use all the time, the barcode scanners that we see everywhere, those work because of quantum mechanics. The transistors in your mobile phones work because of our understanding of quantum mechanics. And that was just us scratching the surface. That was us being able to understand quantum mechanics and leverage those principles. We're now at a point, thanks to incredible work that's being done, we're able to harness and control and build with harnessing the principles of quantum mechanics and unleashing a whole new kind of power that we're able to leverage the power of nature to compute, which is incredibly exciting. And this is happening now, and I think I was the last generation to grow up without the internet. And I think of young people today as to be one of the last generations to grow up without quantum computing, and just how transformational that's going to be. So it's, to your point, Sabrina, it's a very exciting time to be alive, but we need you. We need everyone to be a part of this because it's going to impact all of us as we move forward, and it's a joy that we're going to get to discover this together.
So, 一言ですね。Last words, right?
Yes, last word.
So, famous last word. So I maybe, again, I really, like somebody who loves Japan, and then I lived here for a while. I also want to say that the globalization. In Japan, we have a lot of technology development. We have a super talented people, and even quantum computing, we are leading in Japan. One of the most frontier technologies, like quantum and HPC integration, even leveraging the deep technology that Japan already invested, which is HPC. Not many countries have HPC technologies, right? So using this power, I want us in Japan, us means Japan, to reach out to the world and then show the impact, and then also help people globally to form the quantum ecosystems, and then using our leadership to show that we can work with other partners in a global level to advance the technology together. I feel like we also need this momentum of going out of the Japan also. Yeah.
Okay. So thank you very much for your great comments, everyone. I think quantum computer is now is a timing, not too late, not too early. So now is the timing to start. So everyone, let's start quantum activity with these global leaders. Thank you.
Thank you very much. Please give a round of applause to all of the speakers.